Hi, welcome to the presentation video of our works entitled Human Presence Probability Map, HPP, a probability propagation based on human flow grid. In this work, we propose a new pedestrian pose prediction model through partial observation of a robot fleet. Pedestrian pose prediction has many domains of application like personal assistance, social navigation or service delivery. This work intends to provide a human presence probability propagation through an existing flow grid. A flow grid learns on each cell the probability to meet pedestrian in a given orientation. Thanks to such information, we build an efficient algorithm to propagate probability to meet a pedestrian on the entire map. Here, an example of propagation. In the given case, a flow grid has been already learned and we simulate a pedestrian observation on the map center directed to the east. Here, an extract of our experimentation. On the left, a HPP map is presented. On the right, two evaluations processes are available. On the top, the HPP metrics is computed according to the distance between ground truth pedestrian pose and HPP cluster centroids. On the bottom, the human affordance metrics, statistical human presence map, is computed in the same way. In this situation, a pedestrian has been detected by a robot. A probability of human presence starts spreading. For evaluation purpose, a cluster is built on HPP, a cluster centroid is computed and ground truth pedestrian poses are affected to such cluster. Distance between ground truth and cluster centroid defines our error measure. Here is an example of combination between learnt behavior, flow grid, and current observation, enhanced by VonMises coefficients. In the same way, for evaluation purpose, clusters are computed on the human affordance map representing statistical human presence. The artificial scenario is composed of 4 robots covering the entire map. During their mission, robots update both flow grid and HPP map. For evaluation purpose, the distance between pedestrian ground truth and human pose prediction models, HPP, human affordance and Kalman estimator, is computed all along the experimentation. Experimentation has been conducted both on artificial scenario, left side, and ATC real pedestrian pose captures, right side. The table shows results on both scenario. Several tests have been conducted. First 2 baseline algorithms have been tested. One long-term prediction approach, human affordance map, and a second one short-term approach, Kalman estimator. Then several variants of our HPP algorithm have been done, one without VonMises coefficient optimization, a second with and a third with VonMises coefficient and a flow grid already learned. The table highlights the fact that our approach overcomes the other human pose prediction models whatever the pedestrian tracking duration is. The only exception is on one long-term tracking, up to 800s without observation updates. Here statistical approaches like human affordance are better.